So in this video lecture we will deal with mainly kinematics. So before moving into the depth of kinematics, let's talk about the definition of kinematics. It is the study of various parameters related to motion like velocity, distance, displacement, speed, etc. without dealing with cause of motion. Without dealing with cause of motion. The cause of motion is force actually. And in this chapter we will not deal anything with force. So in this chapter we will only be dealing with velocity, displacement, distance, speed and similar other parameters. As far as kinematics is concerned, it's a topic which is used everywhere, be it electrostatics, be it optics or whatever you take, there is always a need of kinematics. So it's one of the fundamental chapters and that's quite easy as well. So before getting into the depth of kinematics, let us know the concept of point object, which is a very simple thing, but I would like to mention it. Concept of point object. So this concept of point object says that uh, whatever be the size of object, whatever be the size of object, we will treat it just as a point object. Whatever be the size of the object, but we will always deal the object to be just like a point object. We will not consider the size of the object while dealing the things in kinematics. Next to it, let's talk about the next concept, which is also a simple thing, a concept of rest or motion. I'll tell you it with the help of an example.
Now here we will deal with the concept of rest or motion. Let's say for example, I would like to say that no object in universe is absolutely at rest or in absolute motion. In universe there is no object which can be said absolutely at rest or which can be said absolutely in motion. Actually the point or the discussion of rest or motion is dependent on the observer. So it always depends on observer, who the observer is, and the observer will decide whether the object is moving or not. For example, let's say there are two persons sitting in a train and the train is moving with some speed, let's say 10 or 20 or maybe something like that. So let's say this is a train moving with a speed of 10 meter per second in this direction, and there are two persons, uh, A and the other person is B. The whole train is moving with speed of 10, and the mother of A and B is standing on this platform. She is mother of A and B. Now if I ask A whether B is moving or not, then A will say that B is not moving as seen by him. So A will say that B is not moving, while if I ask the same question to mother whether A or B, or in fact if I ask mother whether B is moving or not, then mother will say that B is moving. So mother will say B is moving, but A will say B is not moving. That's why I can say that the phenomena of motion of B depends on observer. If the observer is mother, then she is saying that B is moving, and if the observer is A, then observer A is saying that B is sitting in front of me at a distance of, let's say, 5 meter, and he is always at a distance of 5 meter from me. So B is not moving as seen by A. So that way we can straight away tell you that the concept of rest or motion depends on observer, who is observing the whole picture or the story. Now after discussing the concept of rest or motion, I would like to tell you, or I would like to discuss a couple of points like distance. These are the parameters related to motion. If I talk about distance, then I can straight away say that distance is the total length of path, followed by object between initial and final point. For example, let's say a person moves from this point A to this point B. If the person is moving from this point A to this point B, then the total length of the path traversed by the object is the distance traveled by the object. So this total length is the distance. I can say that distance is a scalar quantity. Its SI unit is simply meter, as all of you might be knowing. There are a couple of important properties that distance follow, like distance can never decrease. Distance can never decrease. Distance can never decrease. For example, let's say if I have a car and the car is, let's say, standing at this point A. Now if the car moves and goes to this point B, and again if this car comes back to the same point A, that is it at its starting point, then I can say that the distance traveled by the car is between from A to B and B to A again is, let's say, 20 meters going and 20 meters coming back. So the total distance is 40 meter, not 0. 0 will not be the distance covered by the car. If the car is moving, then the distance covered by the car must increase. So distance can never decrease. Even if I move from this point A to this point B and comes back to my original position, even then I would say that I went 2 meter in forward direction, I came back 2 meter in backward direction. So the total distance covered by me is 4 meters. Total distance covered by me is 4 meter, not 0. So that way we can say that the distance is a scalar, its SI unit is meter, and distance can never decrease. One more property of distance is that distance cannot be negative. Distance cannot be negative. I will never say that I moved from Jaipur to Delhi and I traveled minus 250 kilometers. I'll always say I have traveled 250 kilometers. So distance is always positive. So that is why I can further predict a couple of more important things, like let's say if I am given a graph between distance and time, then such a graph is not possible because distance is decreasing in this graph with time. So such a graph is not possible. In fact, even if I draw a graph like this graph is also not possible because distance cannot be negative. So these two graphs are not possible at all. In fact, we will deal all the graphs between distance time, speed time in a different section, but for the time being, I wanted to tell you these points. That's why I discussed them with you. Now let's talk about second parameter, which is also an important parameter. This is displacement. It is the shortest directional distance between initial and final point. Some of the people may object my writing distance in this definition, but I think that this language makes a student understand the definition in an easier and a better manner. That's why I've used this word distance. So let's say if an object moves from this point A to this point B, then this is the total distance covered by the particle. But I'm saying that displacement is the shortest directional distance. Shortest distance between initial and final point is this. The straight line joining A and B is the shortest distance between A and B. And if I add direction to this shortest distance, if I add direction to it, then it becomes displacement. Uh, this becomes displacement. So adding arrow to distance to the shortest distance makes this shortest distance a vector, which is displacement. So if I deal with a couple of properties of displacement, then I can say that it's a vector quantity. Its SI unit is simply meter, and the limitations that were there with the distance time graph are not present with displacement time graph, because displacement can decrease, and even it can also be negative. This displacement can decrease, unlike distance which cannot decrease. It can be negative, unlike distance which can never be negative. So these are the basic differences between displacement and distance. Now let's take an example. For example, I have a circle and an insect situated at this point A starts moving along this track to up to this point B. Then if I'm asked that what is the displacement and what is the distance covered by the insect in moving from point A to point B, I want to ask two questions. Distance A B, which is the length of arc in fact. B, displacement A B. I want to ask displacement. It's a vector quantity, so I want to calculate the magnitude of displacement, and I want to calculate distance, which is the length of the arc. So if I remember, in fact if you people remember, then you can recall that the definition of theta says that theta is equal to length of arc upon radius. That way length of arc can be written as r into theta. So the length of arc is r into theta, which is the distance of the particle, distance covered by the particle or the insect. Similarly, if somebody asks me the displacement, then displacement will be the shortest distance joining the initial and final point, which is this in this case, and which is this in this case. And in order to calculate this minimum distance between A and B, what I'll do is I'll use a bit of geometry and I'll just drop a perpendicular on this blue line, and this is a bisector, so this angle will reduce to theta by 2. This is the radius of the circle, and I can write that in triangle BOD. In triangle BOD, sine theta by 2 is equal to perpendicular, which is this distance. This is the perpendicular. So perpendicular upon hypotenuse, perpendicular upon hypotenuse. So perpendicular becomes r sine theta by 2, and the total straight line or the shortest distance between A and B is simply double of this perpendicular length. So that is equal to 2r sine theta by 2. So this is the displacement, and this r into theta is the distance traveled by the particle. So that this example have I think that this example has cleared the distinction between the displacement and the distance. We can further take one more example. For example, let's take this. There is a wheel given here. The radius of the wheel is, let's say, r, and this wheel rolls, and this wheel was having a red mark. This wheel was having a red mark like this. Let's say this red mark is named as A. Now this wheel is rotating, or rotating with the angular velocity omega. So as soon as this wheel covers angle pi, this point A will get moved to this topmost point, and the new position of the wheel will become this, and this point A will move to this position A dash. If the wheel is not slipping, the ground is not slippery, and the wheel is not slipping, then we can straight away say that this point has moved up, this point has moved down. So the wheel has covered this distance. This distance has been traveled by the wheel on the ground. So this distance can be told as pi r. So if this is pi r, this is very apparently 2r. So the displacement of point A from position A to point A dash can be told as displacement is equal to pi r square plus 2r square and under root of this. So this is the displacement of point A. So the question was, find displacement of point A, and we found the displacement of point A as it moved from this position A to this position A dash. This way we can find the displacement of point A. Thank you.